Hey guys, I'm Mr. C and welcome to our geometry lesson on transformations. All right, so this is the warm-up that you guys were looking at. Describe the transformation. Okay, so this was called a translation, or you could informally call it a slide. Basically, you just take this triangle and slide it over and slide it up. So yeah, I guess technically we would call that a translation. Right? Name the coordinates of the pre-image and the image. Okay, so I guess what I do is first of all, what the heck is the pre-image, right? And what is the image, right? So the pre-image, right, is this thing right here, what you're starting with, and the image, or the image that it's after it's translated. The way that you know this, the original thing doesn't have the little dashes, and the new thing does, right? So I guess the pre-image, I guess what I would say is that A is, what do we got? -5, 1, right? B is, looks to be -2, 5. And then C looks to be -2, 1. And then the image, right, is this new thing after we kind of shifted it over. And the way that I recognize it is that it has that little dash there. And so we would call this, I guess, 1, 3. We would call B, the new B, 4, 7. And we would call the new C, looks like 4, 3. Okay. And then what quadrants are the triangles in? So I guess we'd have to say the original image is quadrant 2, and then the new image would be quadrant 1. Now, those of you guys that are unfamiliar with this lingo of the quadrants, basically quadrant 1, where everything's positive, quadrant 2, where the x is negative, y is positive, quadrant 3, everything's negative, and then quadrant 4, where the x is positive and the y is negative. So kind of goes, I guess, counterclockwise from the positive one. And then is ABC congruent to the new ABC? And the answer is yes. Yes. And in fact, as you guys will come to find out, many of these transformations are just taking the same triangle, or same image, I guess I should say. It's not always a triangle, and moving it around, whether it's being slid around, flipped around, twisted around. But 3 out of the 4, you're getting congruent images when it's all said and done. And then the fourth, teaser alert, spoiler alert, dilations is a little different, where you'll end up with a similar figure. And similarity, if you guys remember from the last lesson, means same shape, different sizes. Okay, and here they are. These are your quick notes. All right, what we just reviewed there was translation, where the figure is just, you slide it around. So you've got the pre-image and the new image, right? And then reflection is it's flipped, right? Rotation is it's, I guess, turned around a point. And then dilation, where it is enlarged or reduced. A couple of things just to be aware of. If you're reflecting anything, you have to have that mirror, or that reflecting line. It's always going to be reflected over something. You can't just say you're reflecting something unless you have a mirror, unless you have a line that is being reflected over. And same thing is true for the rotation. You can't just say you're rotating something unless you have that pivot point, right? That point in which it is being rotated around, right? Now that point could be on one of the figures, or on the original figure, or it might not be. So that's something to be aware of. And then dilation, you guys may remember we touched upon this in the previous lesson, but dilation, right, you also have to have kind of that center of the dilation, the place of which it's being kind of zoomed in and out from. And we're going to, of course, talk about all of this in much more detail, but that's the overview. So those of you that have taken geometry before, this is a review, right? Those of you that haven't, right, this is going to be brand new. This is going to seem unfamiliar. It may seem scary. Keep in mind, though, when you do your IXLs tonight or whatever, you can always ask for an example. So you can click show me an example, right? And it will show you how to do whatever the type of problem is that you're trying to do. So hope that gives you a little peace of mind. And obviously, myself, Mr. Gnally, are here at your disposal. Ask us any questions you like. Anyway, let's keep moving here. So IXL preview. All right, I'm not going to sugarcoat this. We are giving you a ton of IXL assignments tonight. I think 8, right? And there's a reason for that. This kind of math, transformations, is much better. You got to do it, right? We can't just talk about it theoretically, right? We can't just show you a bunch of equations, right? This is stuff that you actually got to do. It's hands-on. Those of you guys, that your mechanics or any sort of trade where you're moving shapes around and all these kind of things, right? You can't just like talk about it. You got to do it, right? And that's why there are so many IXLs assigned. Mr. Gnally said, hey, try to shoot to like, 3 to 5, and I just loaded up 8 because it's the only way for you guys to really experience this and to really get this. Anyway, enough talking about that. What combination of transformations is shown below? Okay, so first of all, right, 1 to 2, right, all that's doing, we're sliding it over, sliding it down. We call that a translation, right? So it's one of these two, right? It's not this, it's not that, right? And then what are we doing next? Okay, so then 2, it looks like it's being reflected. Now, like I said, anytime you do a reflection, there has to be a mirror, right? This could be the mirror that this is being reflected, right, onto that, right? Now, I know there are different ways to do this. I mean, you could argue that maybe this was a rotation over some particular point. No, it couldn't be because you're going 1 to 2. If it was 1, 3, 2, okay, you'd have an argument at a rotation, then a reflection, but it's not. It's 1, 2, 3. So actually, there's only one correct answer: translation and then reflection. Okay, and that's kind of advanced. You're putting a couple things together. We're just asking you, what are they doing? All right, now we're going to get into specifics of more of these things. So quick notes translation. Okay, yes, that is the warm-up. We already talked about it. I'm not going to waste your time and talk about it anymore. But what's happening here is basically this triangle is just being slid over and slid up, right? Okay, IXL preview, a translation. Graph the image of EFG after 4 units down, 4 units left and 2 units down. Okay, so here's my thing, right? This is going to make these types of problems so much easier, right? I know you're tempted to kind of go crazy, try to do all of it once, but if you do this, this is all you're going to know. 1 point at a time. That is the secret to this whole unit, if we want to call it that, lesson, if we want to call it that, right? 1 point at a time. Right? If you do 1 point at a time, it's going to be pretty straightforward. If you try to do more than that, it gets very overwhelming very quickly. You may have the ability to kind of shift shapes in your mind. If so, great, right? But for the vast majority of you, 1 point at a time will serve you very, very well. So 4 units left. Okay, so I'm taking, like I said, 1 point at a time. F, I'm going 4 units left, right? 1, 2, 3, 4. And then I'm going 2 units down, 1, 2. And then what I have here is the new F. Okay, now E. I go over 4, I go down 2, and what I have is my new E. And then G, same thing, 1, 2, 3, 4, 2 units down, I've got my new G. Okay, boom, 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 I have translated, I got my new figure. Now I know this is probably going to be a little easier maybe on the actual computerized MCAS because you can move things, using the computer. You don't have to worry about, what I was just doing there. Or maybe harder for you, I don't know. But for many students, you guys are so good with computers, it's probably going to be easier. But notice, with 1 point at a time, it was very, very easy. If you try to do more than that, your chances of making a mistake go up exponentially. So anyway, that's just my 2 cents. Take it or leave it. All right, so another IXL here, right? The coordinates of the vertices after you translate 5 units left and 6 up. Okay, So this is basically asking you to do the same thing, except just name the coordinates, right? So in geometry class, right, you know, your teachers had you do this in a few different ways, right? You draw the coordinates, name the coordinates, right? Just anyway, 5 left and 6 up. Remember, 1 point at a time. So S, 1, 2, 3, 4, 5, right? And then let's draw it out. 1, 2, 3, 4, 5. So you can visualize it. I'll just do this with the first point. I'm not going to continue doing this. Okay, so that should be my new S. All right, cool. And I'm going to do the same thing with each of these, right? So my new R, it looks like I'm going to go over 6, excuse me, over 5, up 6. Okay, so it should be right here, I believe. You might want to check me on that one. And then my new T, right, over 5, 1, 2, 3, 4, 5, up 6, 1, 2, 3, 4, 5, 6, up. My new T. And then finally my new U, same thing. Okay, and then I have my new thing here. Okay, of course it wasn't asking us to draw it, it was asking us to list the coordinates, and I will do just that, right? So anyway, and by the way, if this is boring for you, if you kind of already knew this, well, hey, skip ahead on the video. Wait till find me on a new problem. Here, -3 up 2. Okay, here we've got 0, 3, I believe, and then U would be 0, 2. All right. So just basically doing the same thing, just asking it in a different way. And we want you to kind of be fluent with coordinates, pictures, right? Anyway, I know if you got one, you probably got them both, but hey, doing this in different ways, that's how you learn it better, and that's how you're going to prepare yourself for this MCAS test. Okay, now rotation. Right? Translation is pretty simple, relatively simple, right? You're just shifting things, right? Rotations can get a little more complicated, right? Now, first of all, what's happening here, I'm not going to write this all, I'm going to talk you through it. What's happening here, okay, it's rotation. No surprise here, it is rotating. And specifically, right, it's rotating about, remember, you got to have that pivot point, and that pivot point here is the origin. In your geometry classes, I think your math teachers always made it the origin. It may or may not be the case on the MCAS. You may be rotating about a different point, which, again, you're going to use your problem-solving strategies to get those problems right. Right? Just keep in mind, the majority of these test questions are multiple choice, some of which you actually have to do it on a piece of paper or open response. Actually, it wouldn't be a piece of paper, it'd be on the computer. But either way, you're using your skills, your logical thinking, your problem-solving ability to solve questions that may not be as straightforward as things that you've seen in class. Okay, now name the coordinates of the pre-image and the image. Okay, I'm not going to waste your time with this, but what I am going to do is I'm going to say this is the pre-image, and the reason I know it is the pre-image is because it does not have the little dashes where this is what we call the image, or the new image, I guess you might call it. All right, what quadrants are the triangles in? By now, you guys, we reviewed that a little bit. It looks like it's 1 and 3 specifically. This is the 3 is the pre-image, 1 is the new image. And is ABC congruent to the new one? Yes, it is. Yes, it is. In fact, anytime you do a rotation, you will end up with congruent figures. Okay, so IXL preview. This is tough. I'm sorry that this didn't come out more clearly. It will be very clear when you see it on IXL. But they're asking, which of these is rotated 110 degrees clockwise about Y? Okay, so the reason I wanted to just draw your attention to this is you are rotating on the fixed point, point Y. Now, the truth is, this one here, oh no, I'm sorry about my tablet giving us trouble. Let's see if I can refresh this and get back to it. Okay. Thank you for your patience, you guys. Okay, here we go. Okay, let's hope for the best here, you guys. Okay, so first of all, we got to know this is wrong, right? Because it's not being rotated on Y. It's being rotated somewhere else. Something else is happening. But we've got a 3-horse race here because all of these could be rotated on Y, right? So now the original triangle, which has been drawn in purple for us, is rotated 110 degrees counterclockwise. Okay, so this one, and by the way, just to be clear, 110 is less than 180, right? That's a good vantage point because 180 would be kind of a complete twist. And anyway, so this one looks like it's rotated clockwise, right? So that's why I'm going to call this one wrong, right? This one, okay, so I guess this is, I guess I would say this is rotated counterclockwise, right? And it looks like it's less than 180 degrees. So that's possible, right? Now this one here is also rotated counterclockwise, right? But not as much. Okay, so this is where this is tricky, right? I mean, which one of these is correct? I mean, you know, you could make an argument for both of them, but it comes down to that 110 degrees, right? Now, first of all, let's talk about what it would mean, right, if this was rotated, let's say XY, or excuse me, YX, I guess I could call it either one. If it was rotated 90 degrees, right? Boom, this is what it would look like, right? So this is 90. If it was rotated 180 degrees, it would look like this, right? So just to be clear, I'll call this boom, boom, right? I'm putting a question mark here just to make it clear that this is what I'm talking about, right? And now if 110 degrees, so that would be 180, right? So I'll call that 180. 110 would be a little more than 90, but not quite as much as 180, right? So again, this was just, that is not the line we're talking about. This is not the line we're talking about, right? This is a 110 degree counterclockwise rotation. Which one of these is more closely represented? All right, I'm saying this one. Okay, why am I saying that? Well, here it looks like, if I'm going to say like, it looks like that could be 110 degrees because it's more than 90 degrees. Whereas this one here is actually less than 90 degrees, right? That is why I'm saying that this is the right answer. Okay, again, you see, these are kind of, there's subtlety here, right? There's, as you guys will see on the MCAS, as you guys experience on the MCAS, typically out of 4 choices, 2 of them tend to be obviously wrong. But then the other 2, there's a little subtlety, and you really have to use your math in order to figure it out. Okay, another one here, graphing the image. Okay, so now this is where you might have to use your formula. Now, the formula. Where is the formula? Did I give you the formula? Oh my goodness! What the heck? Okay, I put this one out of slide. Okay, I am sorry for this. I will correct this by the time we go to class. All right, but anyway, hey, my apologies. This will be corrected. But let's first of all talk about what are they looking for here. Okay, so a 270 counterclockwise. Now, that is meant to throw you off. It throws you off, it should, right? But just remember, 270, right, is the same, 270 counterclockwise is saying 90 degrees clockwise. Okay, all right, now, luckily it is about the origin here, right? So what this new thing will look like, right, is it's going to be rotated 90 degrees clockwise. So the entire thing should be in this quadrant here. Okay, now what I'm going to do is I'm going to show you the formula. Okay, now before I show you the formula, I want you to logically think about this, right? If you were just to kind of take this paper and twist it, right, this E, the new E would be here, right? Right, the new D would be somewhere, I don't know, 6 over 3 would be somewhere like over here, right? And that's what's going to happen, right? Now, some of you guys can just do that. Visually, it makes so much sense. Logically, it makes so much sense. Some of you guys are going to want to use the formula, right? So 90 degrees clockwise, I'm going to see what the formula is for that. Again, I'm sorry to put these out of order. 90 degrees clockwise. So basically what you do is you flip them and you switch the new x. Okay, so anyway, or the new y, excuse me. Okay, so so xy, for every xy, right, you flip them and you change the sign of the new y. Okay, so again, this is 90 degrees clockwise. And you are going to see this all over the MCAS, right? They're 90 degrees clockwise. That would be the easy thing to tell you. No, they're going to tell you 270 degrees counterclockwise, maybe, right? But just remember, it's the same exact thing. So all I'm going to do here is for every single point, right? And I'll even write the points, right? Let's just do this. Let's do this step by step together. Remember, our mantra is that the word? It is 1 point at a time, right? So I got E, D, C, F. Okay, so in each case I have my original. So it looks like -3, 0 is my E. D is -7, -3. C was -7, -8. And then F is -3, -5. Okay. Now, for each of these, I flip-flop. I got 0, and then -3 will become +3. All right. And here we flip-flop, so we got -3, but then 7, we're going to change the sign. We're going to make it +7. Over here, we flip-flop. We got -8, but again, we're going to change the sign on the new y, making it +7. And then finally, F, we flip-flop, and we change the name, the sign on the new y. Okay. All right. Now, you do have kind of a safety net here, is that if you're thinking of this logically, right, if it's 90 degrees clockwise, like we just said before, everything is going to have to be in quadrant 2, right? Because this is entirely in quadrant 3. So if we really are rotating 90 degrees clockwise about the origin, everything should be in quadrant 2. So now what I'm going to do is I'm going to graph my new E, and I will label it appropriately. I'm going to graph my new D, and I will label it appropriately. I will graph my new C, -8, 7. There we go. And my new F, -5, 3. Okay, now assuming I did it 1 point at a time, assuming that I was careful, right? This should be a correct rotation, and maybe a way to do it, if you want to like look at the original one, and then kind of twist your head and visualize it in quadrant 2. You can even take a picture and twist it, whatever works for you, right? If you really want to visualize this. But anyway, that is their problem, using the formula 1 point at a time, which is, hey, that's a safe way to do it. Okay, now on to reflection. Okay, so reflection, right? Again, it needs to be reflected over a particular line. So you see your line here, right? And it's basically, wait, what's the transformation? All right, obviously it's reflection, right? The length of NP, right? So this one here, right? Because it's this 9 unit thing, it's going to be 9. It's congruent, it's just reflected. And then angle M, right? Remember, M is the same as J, right? So that's going to be, we call that 48 degrees. Okay. The point being here that when you reflect something, just as when you translate it or rotate it, you have a congruent figure. Okay, now IXL, you asked it to reflect. Now, an important thing here, reflected about the y-axis or across the y-axis, right? So, so my new B, if it was 2 units away, the new B is going to be 2 units away. A is 2 units away, same thing, 2 units away. C is going to be, I guess, 10 units away. Okay, right, there we go. Okay, and that's that. Now, how are you going to make a mistake on that? Reflecting it over the wrong thing, right? If you reflected it over the x-axis, it would have been wrong. Sometimes you will be asked to reflect over like a line, like y equals x, or maybe even like a horizontal or vertical line, like y equals 1, right? And those can be a little trickier. They can be a little trickier, but again, if you do it one point at a time, it's going to be a lot easier than if you try to do it all at once, right? So what was my technique here, right? Since I'm reflecting over the y-axis, I know there's not going to be any up-down shift, and I know that if it was 2 away from the y-axis, it's going to be 2 away again. And I did that with every single point throughout. This next one here, same exact thing, except reflecting over the x-axis. So yeah, you got your new f, you got your new e, right? Right, again, since it's over the x, there is no side-to-side shift, right? And if it's 2 away, it's 2 away again. And the new d, right, is, I guess it was 6 away. Well, it's going to be 6 away again. And then the new c, is if it was 6 away, it will be 6 away again. And here's the thing, you guys. I know that you guys know how to like write coordinates. I don't want to bother you there. Maybe just hear me. I'll say c. Okay, so c. Let's see, what was it? It was -3, 6, I think, right? Okay, it makes a lot of sense. Okay. All right, next. Okay, so this is a real MCAS question. It's probably going to ask us to do a bunch of things. Triangle ABC is shown on the coordinate plane. It is reflected, then translated. Okay, so they're asking us to do, okay, so reflected and then translated. So first of all, it is reflected across the x-axis, very important there, right? So we've got A, looks like C would be here, and then B looks like it was 3 away, it'll be 3 away here, right? So that is our reflected over the x-axis, and then translated 3 units up. Okay, so again, each one of these points, I'm going to go up 3, 1, 2, 3, up 3, and then up 3. Okay, so here we have it. This is my new A. Remember that this was B after we reflected. Remember that this was C. Okay, and that's what you are going to be asked to do. You typically aren't going to be asked to just do one transformation. They're usually going to try to throw a couple at you to try to throw you off. Okay, now, dilations. This is different than the other three in the case that you're not ending up with a congruent figure. You're ending up with a similar figure, right? And anytime you do the dilation, there has to be a center of dilation, right? So very often in your geometry class, you are just asked to dilate from the origin, right? You're trying to keep it simple for you guys. Now, on the MCAS, you may be asked to dilate from other points, right? This is an example. The center of dilation is over here, right? Again, use your test-taking strategies. Use what you know to logically think through the problem, and you will be able to answer many of these questions, even if the center of dilation isn't 0, 0. And this is, I know I keep saying this, but you cannot freak out on this test, right? That is your worst enemy, right? Just think through, how can I find a way to solve this problem, right? These standardized tests never give you problems exactly the way you learned it in math class. And that's not just for you guys, that is for every math student in the state of Massachusetts, right? Unless, of course, they're studying MCAS questions explicitly, like we are right here. But anyway, just be ready for problems that are slightly different than the ones you did in class. Okay, this, again, my apologies, it wasn't supposed to be here. Describe the dilation shown using a center point for the scale factor. Okay, so first of all, this one here, and I'm going to, spoiler alert, right? The center of dilation is actually 0, 0. And how do I know that? Right, one way, I'm just going to write all these coordinates. So here we've got A is 2, 1. Okay, B is 5, 1. Okay, and then C is 3, 6. Okay, now I'm going to look at the coordinates over here of A, B. You can also call that, some people like to call it A prime, B prime, C prime. If that brings you happiness, then do that. It's A prime, we got 6, 3. B prime, we got 15, 3. And then C prime, we've got, what is that? 9, is that 9? 9, 18? 9, 18. Okay. And what you guys will notice that all you did for each one of these is you just multiplied both the coordinates by 3, right? And you do that for every single one. And that is because the scale factor is 3. The origin is the center of dilation. So anyway, I guess I'll say 0, 0 for center point, given the answer to the question they were asking for. And the scale factor was 3, which basically means the x and y's were simply multiplied by 3. And that's all you have to do if the center of the dilation is the origin, which is what it is in most cases, if you're actually asked to come up with all the coordinates. So that's, unless the teacher or the test maker is trying to be exceptionally mean, that is the types of problems you guys will see. Okay, now here, dilation, an example in your IXL, graph the image after a dilation of scale factor 1/2 centered at the origin. Okay, so this is fantastic, centered at the origin, as most problems will be, right? So if it's 1/2, now just to be clear, right, this has point -4, m is -410, right? All you are going to do is divide by 2, or actually maybe I should say multiply by 1/2. Same thing, right? And your new m will be -2, 5. Oh, no. Oh, my goodness. I'm sorry. 10, -4. What are you doing, Cotter? Flip-flopping the old XY flip-flop. I'm sorry about that. -2. Okay. So anyway, 5, -2, right? That is your new m, right? And then the L, all right, if our original point was -2, 8, all we're going to do is multiply both of those by 1/2, and we are going to get the new L, which is -1, 4, right, which will go right here, new L. And then same thing for K. If our original was -2, -8, right, we just divide both by 2. We get our new K is -1, -4. -1, -4. Okay. The new K. All right, and here we have it. Anyway, so dilation centered at the origin, pretty simple, right? You just multiply all the coordinates x, y's by the scale factor. Okay, so an MCAS question here. A series of transformations will be performed on a figure that is graphed on a coordinate plane. Which of the following series of transformations would produce a congruent figure? So just remember, right? Oh, this is good. You're gonna collect, there's more than one correct answer. So remember, some of them give you a congruent figure, some of them don't. Specifically, right, out of the 4, right, transformations, just sliding the congruent figure around, right? Reflection is just flipping a congruent figure, and then rotation is just kind of rotating or turning a congruent figure. Dilation is the only one that is either, either making it bigger or making it smaller. So with that in mind, let's see which correct answers we get. Which of the following would produce a congruent figure? A translation followed by a reflection. Okay, so both of those, translation and reflection, both do not change the size of this thing. So I will say that is correct. A reflection followed by a rotation. Okay, again, reflection and rotation. Neither one of them change the size, so I'm going to say that is correct, congruent figure. A dilation, scale factor 2. Nope, the dilation is what made it not congruent. C is not right. D, dilation scale factor -1. What? What the heck is that talking about? All right, okay, reflection's cool. I don't even know what's going on here, right? Let's talk about E. A dilation of scale factor -2 followed by a dilation of scale factor. Okay, all right. What the heck does it mean to have a scale factor of negative? Okay, so first of all, remember what this means. You are multiplying every xy coordinate by -2, right? So that is not going to end up with a congruent figure. right? Now you might say, hey, but then you're gonna have a scale factor 2. Sure, I multiply something by -2, then I multiply it by 2, I end up multiplying by -4. Either way, I'm changing the size of this thing. Okay, so this is not right. Now they told me there's 3 correct answers. How the heck is this correct? Well, let me explain why. All right, let me explain why this will not change the size. Because if you multiply every xy by -1, you're going to change the location of it, but you will not change the size of it, right? So let's say I've got my triangle here, right? And I multiply every x and every y by -1. Okay, sure. Everything's going to be over here, right? Everything that was positive will then become negative, but the size of that will not change. This is a tricky question. I mean, I'll tell you what, A and B were layups, right? C was obviously wrong. E was confusing, but now that we've talked about it, obviously wrong. D is the tricky right one. Okay, anyway, I hope that was helpful for you. Okay. All right, wait, what the? Hold on, you guys. Okay. So what's going on here? Oh, you know what this was? These were the answers to the other one. We did it out, so I didn't show you the multiple choice. Anyway, hey, for the video, I'm sorry, a couple of these slides are out of order. Guaranteed by Wednesday's class, we're gonna correct it. Anyway, thank you for your patience. Anyway, we did a lot today. Like I said, you guys have been killing it on the IXL. Keep that up. I know there's a ton of IXL assignments today, but remember, the only way to really do these or learn these is to actually do them. That's why we're doing what we're doing. If it's easy for you, just do 1 or 2 problems and skip to the ones where you need a little more help. Anyway, I'm Mr. C. Thank you for watching this video, and we're going to see you on our next class.